Hi and welcome back. My name is Joshua. I'm excited to be back again in the new year. This is my first video for the year 2022. I want to wish us a happy new year and as well appreciate us for our support in the previous year and crave for more of it in the new year. In my last video, that was in 2021, what we talked about was on matrix. And so this year we would continue from where we discontinue on the concept of matrix. But quickly, let's have a recap on how we can create a matrix in our programming. So I'm going to create like a vector, and I call this vec, a variable called vec, and I'm using the vector function. So I use the assignment operator, and then I use the vector function, and I just want values ranging from 1 to 6. So when I run this, when you check the global environment, a vector has been created that is of the class integer and has values ranging from 1 to 6. So if I'm to create my matrix, very easy, I would say this is math. Okay, don't let us use math. I would say this is math double T, and then I'm going to say matrix. I will supply vec, the variable, as the data, and then how many rows do I want? I want 3 rows. How many columns? I want 3 columns. So when I run this, a matrix is created as a matrix of the dimension 3 by 3. So to see the matrix, just print math and then you run it. So we have it at the level of the global environment. So when you check this particular matrix we have created, one thing you would see is it doesn't have a name for the level of the rows, and again the levels at the column. So in the last video I could remember we learned something on row names, column names, row sum, column sum, etc. So let's just have an example. For instance, I can say call sums of math, and so when you run it, it performs the column summation of all the values we have on the column. So this is 1 plus 2, 3, 3 plus 3, 6, this plus this gives 15, etc. So you can also do the row sum. The row sums, it's a function from the base package, and you say math, and then you run, it gives you a different result, adding everything on the rows. So you can check the previous video for more of these functions, but I'm going to talk about a function which I would start using in subsequent videos, and it's just about how you can give names to both the columns and both the row. So you have the understanding that the matrix is of the dimension 3 by 3. So if I'm going to give a name to the column, I'm going to create a vector. I'm going to say, okay, let me just go straight because of time. I'm going to say call names and supply the matrix as the argument, and then I'm giving it a name on the level of the column. So the columns are just 3. When you check the dimension of the matrix, it is square matrix 3 by 3. So I'm going to give it a name. Let's say AC, that's the first, BC for the second column, and then C small c for the third column. So if I run this and then I print my math again to see the effect of what we have done on the math, so you will see now the columns are not just having values and the comma. Now it is now being named. So the first column is named AC, second column BC, CC. The same thing you can do. You can change the row names from it having the square bracket and the value, the numbers and comma, and then you can say row names. Row names is the function, and then you put the matrix you want to give names to its row, and then remember that the matrix has just 3 rows again. So you see the row names, let's say as X, C, YC, and then ZC. So if you run this, if you check math again, you would see the result that everything now has been renamed. But I just introduced us to this concept because of what I will be doing in these subsequent videos. So I'm going to do something again that is very simple. When you look at the global environment, we have a data math and we have a value vec. So I want to clear the global environment, and I don't want to take my cursor to this particular area where I could just press yes. So I would say no. And then we have learned in the previous video when we were talking about vector, how to remove a vector using the rom function or remove. So I want to remove everything on the global environment. So I will say remove list equals ls, and then when I run this, it clears completely everything we have on the global environment. So what exactly are we doing in today's video? In today's video, we are learning how to access a matrix first using a vector. So we'll learn how to access a matrix first by using a vector. So I'm going to go back and recreate the matrix math, and then I have it on the global environment. Okay, oh, I need to run a vec. That's why it's saying object vec not found, because I'm yet to run the code on line 1 since I cleared the entire environment. So if I run this and then I run this, so math is created, and then let's try to access elements that we have in a matrix using a vector. So for instance, I'm interested in just the first 2 rows and the first 2 columns of this matrix. So what I'm going to do is to say math, and I'm going to use the square bracket. Don't forget, anytime you're indexing, this is the building block, this is the basis for indexing in our programming. So I'm going to say, since we are doing this with a vector, I'll say C. I'm interested in just the first 2 columns, so this would be the condition for the column, for the row, and then the other one will be the condition for the column. So if I run this, I just have the first 2 rows and information in the first 2 columns. So mind you, when you are indexing, we've done this. Okay, we've done this in the previous video, but I'm just going to say it again. So when I say math, the first condition will be the condition for the row, and the next condition will be the condition for the column. So that is what we have done here. The math, it's the matrix, and the square bracket, we are introducing that because we want to index, and so I am using vector to index a matrix 1 and 2, that is the first 2 rows, and then I separate them with comma. I use vector again, and I want the first 2 columns. So that is how we can easily index or access a matrix. So one other thing again that we also need to know when accessing or indexing a matrix is, for instance, I could easily say math square bracket, and I can leave the condition for row empty, and then I said please give me the first 2 columns. So what I'm trying to say here is, since I leave the condition for row empty, what I'm saying is that print out all the rows, but only for column 1 and column 2. So if I run this, you would see that all the rows are printed. This is the rows, but it just gives this information for just column 1 and column 2. Imagine if I add 3, so it will print out the entire matrix again. That is for column 1 to 3, for row 1 to 3. And so another way to write this is also to say math and use your square bracket and just leave both empty. If you run it, it's going to give you the entire matrix. So anytime you leave the condition for either the row or the column empty, it prints out everything we have on the row or everything we have on the column. So it is possible for me to say, now give me just indexing again with vector row 2 and 3, and then I leave the column condition empty. So I'm interested in having row 2 and 3 for all the columns. So if I run this, the matrix would be of a dimension 2 rows and 3 columns, 2 by 3. So this is very simple and easy to understand. So it is also possible for me to, like, say I want to index a matrix and then I'm using the negative sign. So when I say index -2 and then I leave the column condition empty, what I'm interested in is I want all the information in row 1 and row 3, exclude row 2 for all the columns. So if I run this, this is what we have. So row 2 is excluded and we have informations for row 1 and row 3 for all the columns. So this is, this is very easy when indexing a matrix. So the other thing we also need to understand is this particular phenomenon that happens when you index a matrix and the result gives. Let's have an example. So if I say math and I'm interested, comma, and I say let's have this one, that is informations in row 2 for all the columns. So if I run this, it prints out this particular thing for me, but not in a matrix form. If you check it, it prints it out in a vector form. Now let's check the class of what we have just done earlier, math, and then 2. If I run this, it tells you this is an integer. So this is really common with arrow programming. So to override this particular effect, what you need to do is to say math, you still write it the same format, comma, but you leave the column condition empty and you say comma, use this additional argument called drop, and you say drop equals false. So if you run this, it prints this out as a matrix. There are conditions when this particular thing will be very useful. There are conditions. So finally, before I stop with this section of the video, I'm just going to say it is also possible to say math and index it with just a complete vector without creating some kind of condition for the row and the column. So this is what I'm going to do. I'm going to say 1, 4, and 5, for instance. So if I run this, look at what will happen. It prints out 1, 4, 5. It prints out 1, 4, 5 for me. Okay, let me okay, you might not really understand this right now, because if you check the matrix, what we are doing is, if you see condition elements in line 1, this is it, the next one 4, and the next one 5, you won't understand. It's going to stack the whole thing and start counting 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me create a new matrix for us to understand this effect. So I'm going to say net, and then I'm saying matrix. So I'm using 3, 4, 6, 1, 5, 2, and 9. So, and I say the dimension is 3 by 3. So if I run this, I have met. So to prove what we have on line 34, I'm going to say met, and I'm using the square bracket, and then I use the vector. Then I said I'm interested in values in position 1, 4, and 5. Now let's see 1, 4, 5. You would see that there is a difference. So when you see the position, this is 1, we have 4 in that particular position, was in 4, 5, was in position 5, 2. Now let's print out the entire matrix met, so I can quickly explain this to us. So when I will be doing some advanced stuff in the future video, it won't look very strange to us. So this is the entire matrix. So when we are doing this in this particular dimension, where we are not specifying any condition for the row and the column, what it means is that we are stacking the entire matrix, and it starts counting from a 1, 2, 3, and then the first observation on the first row, second column, takes 3, 4, 5, 6, 7, and 8. So when I say element in position 1, it prints out 4. We understand that we have 4. When I say element in position 4, it tells me it is 5 days, and when I say element in position 5, it tells me it is 2. So for instance, let's go ahead and say met again. Let me create a space for us to really understand this, and I use the vector, and I'm interested in position 4, position 8, and position 9. Now when I run this, I hope we now understand how we have a value as 5, 4, and the one in position 8 is 6, and the one in position 9 is 1. So this is where we're going to stop on how to index a matrix using a vector. Thank you very much for your time, and thank you once again for choosing to learn R with me. Do have a great day.